Okay, so now we move on to discuss about the advantages of the digital control. So there's a very basic question that we should ask at the beginning is why do we do all this? I mean, we already had a nice theory in the continuous time domain, and we were able to design controllers in the continuous domain. So what is the advantage of moving to the discrete time or the digital domain? So we'll try to summarize some of these here. So the first thing is related to the flexibility, and by flexibility here we mean that the controller can be easily updated if necessary, and this is a very useful quantity or very useful property. I mean, because usually when you design a controller, I mean you'd like to tune the controller so many times. So tuning the controller while being at discrete time controllers is written in many times in software on a microcontroller, which means that you just have to edit some lines of code in order to modify the parameters, for example, of the controller, or even the whole algorithm itself, the whole controller structure. You can modify it in software. While in the continuous time, where, for example, we use discrete components, we use resistors, capacitors, operational amplifiers, these kind of components, in order to implement our transfer function, or the transfer function of the controller as a function of S, for example. So this implies that modifying the transfer function is not that as easy as in the digital control. So this is one important advantage, and this advantage is actually becomes quite useful when we start to talk about adaptive control. This is also one very interesting field of control theory, although we will not be studying it deeply in this course, but it's certainly one important field of the control theory, which is adaptive control. And the idea here is that in many cases, the system which you want to control, the actual system which you're trying to control, can actually vary in terms of its characteristics, and therefore the transfer function of the system itself can change over time, and there can be some variations. For example, temperature can change things. There are, for example, if a plane is flying, after some time it loses some of its weight, for example, due to the fuel that is being burned, or in different stages of moving your car. For example, if you are moving at low speeds, it's different than moving at high speeds. So in many cases, the system itself can have more than one transfer function, or have different transfer functions. So, and if you design a specific controller for a specific transfer function, it will not work if this transfer function is changed. So the idea behind adaptive control is that you can actually change the controller to match the actual system, and this can easily be done in software, in digital control. So this is also one very important advantage. Okay. Another advantage of using digital control, it's in fact less susceptible to environmental conditions. What do we mean by environmental conditions? So, I mean, when you implement a controller in the continuous time, you are using, as I said, discrete electronic components, and these can have varying characteristics. For example, with temperature, with pressure, with different operating conditions can lead to different characteristics of the controller itself. While the digital controller is usually in software, and software usually just remains, it's preserved. It does not change with temperature, and at least it's much less susceptible to environmental conditions. Okay. Accuracy is also one very important thing. Accuracy is a very important advantage of digital control, because when we have a digital controller, I mean, we can specify exactly the transfer function, which is actually, as we will see later on, is going to be in the Z domain instead of the S domain, but we can exactly specify this transfer function, and our only limitation is actually the resolution or the representation of the numbers inside the microcontroller itself, which is usually quite good enough compared to the accuracy of, for example, the resistors and capacitors and these kind of things. So they already have much higher error and much higher inaccuracy in their values. Okay, cost is also one important thing. Cost is also one very important aspect. In many cases, you implementing the continuous transfer function can be more costly. I mean, especially if you want to implement a more sophisticated controller with more complicated architecture. So in this case, the cost can increase quite significantly, while in microcontroller, you only need to have one microcontroller and that's it. So of course, and its interfaces, which are usually quite cheap, especially those days with the like very rapid technology in the digital technology. Okay. Yeah, so this more or less summarizes most of the advantages. Okay, now we can move to a set of disadvantages. Okay, so these are a set of advantages. What about the disadvantages? Okay, so nothing is perfect. So the disadvantages of the digital control, first of all, it's a little bit more difficult to design. So as we will see, analog, I mean, when you design a controller in the continuous time domain, it's usually a little simpler and easier than in the discrete time. So that's one important advantage for continuous versus discrete. Another disadvantage of digital controllers is that you have some loss of information, and most of the loss of information is coming from the analog to digital converter, and in particular from those two operations, sampling and quantization. So sampling reduces some of the resolution in the time, quantization reduces some of the resolution in the values of the samples. So you lose some information, that especially the information that you're obtaining from the sensor, and this means that you're not getting all of the information that you sensed. So in a sense, this might affect your system, but we will see later on that the sensors are quite noisy anyway, and in many cases the noise in the sensor is even much higher than the quantization, the noise due to quantization, for example. There are also additional delays that are introduced in the signal path. So, for example, we have the analog to digital converter, the digital to analog converter. We have the serial, if you're doing some serial communication between the microcontroller and these components, and these are additional delays that are added to the system, and these kind of delays can affect, to some extent, the performance of the system and the stability of the system. But again, if you choose your sampling time to be quite short and you have a relatively fast analog to digital converter, then most likely you won't have these problems. But again, one of the objectives of this part of the course is also to study through experimentation and through simulation how the variation in the sampling time affects the accuracy of our control system design. So this more or less summarizes most of the advantages and disadvantages about digital control. In the next step, we will move towards, okay, so what are the main strategies that we use in order to design a digital controller? And yeah, hopefully it will be interesting.